Hi guys, this is Steph. I had number 5 on homework 6, which says prove C star, which equals the complex numbers without 0, under multiplication has a subgroup of order n for every n is a member of the natural numbers. So first, complex numbers can be written in polar form as cosine 2 pi over n plus I sine 2 pi over n. And then Euler's formula tells us that the polar form can be written as e to the I 2 pi over n. So we're going to look at the cyclic group created by e to the I 2 pi over n for general n is a member of the natural numbers. So since we're working with multiplication, if I did e to the I 2 pi over n times e to the 2 pi over n, it's just like squaring it. Or if I did 3 complex numbers, it would just be like cubing this. So the cyclic group, we're just going to raise them to various powers. So first to the 0 power, first power, second power, third power, and so on to the n until we get to the n power, then the n plus 1 power, and it just keeps going. So we can simplify some of those. So anything to the 0 power is just 1. Anything to the 1 power is just itself. So when we square it, we just multiply, exponent rules, 4 pi over n. Cube it, just multiply, 6 pi over n, and so on and so on. We get 2 pi n over n, and then 2 pi times n plus 1 over n. So we can simplify it again. The first few stay the same. 2 pi over n divided by n. I can cancel out the n's. I get ei to the 2 pi. Here I can distribute the 2 pi, and I get this. So we can simplify it even more. The first 4 stay the same again. E to the I 2 pi is just 1. And then I broke up this fraction into 2 pieces. So e to the I 2 pi times e to the I 2 pi over n. But we know this is just going to be 1, right? So simplify it again. First 4 stay the same. Then I get 1. Then I get 1 times e to the 2 pi over n. So simplify it again. Make it as easy as possible. So the first 4 stay the same. Then I have 1. Then I have e to the 2 pi over n. And if you notice, the pattern starts to repeat right there. Our first 2 terms start to repeat themselves. So, since that's where they start to repeat themselves, this was when we raised it to the n power, well, that means that the pattern has different elements all the way up till n minus 1, because it starts to repeat at n. So this is the cyclic that is what the cyclic group creates. So how many elements does that have? Well, it goes from 0 to n minus 1, so it has n elements, which means that the order of e to the I 2 pi over n is n. And that's it. Hope that made sense.